This is a weekly summary of interesting news that is relevant for my distributed systems lecture at the Eastern University of Applied Sciences in Switzerland. My name is Thomas Bocek, and today we will discuss 4 topics. The first topic is about Bitcoins. It's the following topic here. This article reports that Iran is now demanding Bitcoin payments from oil tankers passing through the Strait of Hormuz. This waterway handles roughly 20% of world's oil traffic. And the process works like this. Tanker sends their cargo details to Iranian authorities, who then set a fee of about $1 per barrel. Payment must be made in Bitcoin. Empty ships pass for free. Ships that skip the process receive a radio warning, and vessels attempting to transit without permission are threatened with destruction. And Iran chose Bitcoin specifically because the funds cannot be confiscated under sanctions. A fully loaded supertanker carrying 2 million barrels would owe roughly $2 million, all settled in Bitcoin. After the announcement, Bitcoin jumped from around $68,000 to nearly $73,000 in hours. More than $400 million in short positions were liquidated within 24 hours, and oil prices dropped about 15%, while Bitcoin and gold went up. Some analysts project Bitcoin could reach $75,000 in the short term, with a $100,000 target if global instability continues. Others point out that Bitcoin still behaves more like a high-risk asset than a safe haven. And the situation remains uncertain. The current ceasefire is only 2 weeks long and could collapse even before the 2 weeks. And this is an interesting use case for cryptocurrencies in situations where you do not trust the other party and you also do not trust their financial system. Bitcoin operates as a decentralized network with no central authority that can freeze or reverse transactions. That property, which we discuss in the context of the Bitcoin lecture, is exactly what makes it useful here. No banks, no governments, and no intermediary can block the payments. This is the distributed trust model working as designed. Although I'm a cryptocurrency enthusiast, I would much rather see this conflict resolved through rational dialogue and common sense. But here we are, and the technology is doing exactly what it was built to do, just not in the context I was hoping for. The next article is also about Bitcoin. It's about Satoshi Nakamoto. The journalist spent over a year analyzing thousands of old internet posts from the CryptoPunk mailing list, a group of cryptography enthusiasts from the 90s who wanted to use encryption to protect individuals from government surveillance. And one of their main goals was creating electronic cash, digital money that preserves the anonymity of physical currency. And the investigation builds its case on several layers. First, Adam Back had outlined nearly every core element of Bitcoin a full decade before it was launched. And between 1979 and 1999, he proposed on the CryptoPunk mailing list an electronic cash system that would be disconnected from banking, distributed across a network of computers, scarce to prevent inflation, trustless, and publicly verifiable. All of these elements became then the foundation of Bitcoin. He also invented Hashcash, the computational puzzle system that Bitcoin uses for mining, and he proposed combining Hashcash with another electronic cash concept called B-Money, which exactly what Bitcoin does. And second, there was writing analysis. The journalists built a database with over 30 to 40,000 users who had posted to the relevant mailing lists. They filtered this pool using writing habits found in the Satoshi texts, British spellings, double spaces between sentences, specific grammatical errors like confusing its and it with an apostrophe, its. placing also at the end of the sentence and distinctive hyphenation patterns. After applying all these filters to the candidates who had discussed digital money, only one person matched every single criteria. And third is the timeline. Adam Back was vocal about electronic cash on these mailing lists for over a decade. But when Bitcoin actually launched, he went silent. He made no public comment about Bitcoin until 6 weeks after Satoshi disappeared. Then he suddenly became deeply involved, founded Blockstream, a company focused on making Bitcoin network faster, more private and easier to use, hired top Bitcoin developers and built an ecosystem around it. Now, in our lectures, we also talk about the Bitcoin inventor who had been identified multiple times, also as this very same person here. However, this investigation seems to be the most detailed so far. And of course, Adam Back, he denied being Satoshi Nakamoto. The next article is about hardware and that hardware can fail. We also talk about this in our lecture. It's the following article here. This ASIM article describes how NASA built the computer system for the Artemis 2 lunar mission. Unlike Apollo, where critical controls used manual switches, the Orion capsule computer now manages nearly all safety critical functions. And at this distance from Earth to the moon, there is no way to recover from a failure. So the system needs to be fail-safe. And the system uses 8 CPUs running in parallel, organized as 4 modules, each made of a self-checking pair of processors. If a processor produces a wrong answer, that module goes silent rather than transmitting bad data, and the system switches to the next healthy module. They can lose 3 of 4 modules in 22 seconds and keep flying on the last one. A silenced module can reset and rejoin in mid-flight. And the memory corrects single-bit errors on every read. The network is triple redundant, and on top of that, Orion carries a completely independent backup system on a different hardware, on a different operating system, and separately developed software in case a bug takes out all the primary computers at once. In our lecture, we said that hardware will fail eventually. That means you do not prevent failure, you design a system so that when it happens, it is detected, isolated, and recovered from, buying time until a proper repair is possible. The last article is again about Bitcoin. It's the following here. A blog post from an MIT researcher argues that quantum computing is an existential threat to Bitcoin. Bitcoin's digital signatures rely on elliptic curve cryptography, and a sufficiently powerful quantum computer could break them. Google recently published a paper that would require about 20 times fewer qubits than previous estimated. And a co-author suggested a 10% chance such a machine exists by 2030. And Google has announced a target to migrate its own systems to a post-quantum cryptography by 2029. Meanwhile, ETH Zurich just published a new quantum gate technique achieving 99.9% precision on 17,000 qubit pairs simultaneously, showing that quantum hardware keeps getting more stable and scalable. The blog post puts the risk simply: multiply the chance a quantum computer appears by the chance Bitcoin has not upgraded by then. With the numbers above, you can get roughly a 5% chance that Bitcoin stops working by 2030. And there is a proposal called BIP 360 that introduces a new quantum resistant output called pay-to-Merkle root. It removes the quantum vulnerable public key from the chain. It was merged into the official Bitcoin proposal repository earlier this year, but BIP 360 is only a first step. It protects against long-range attacks, but not short-range ones. A long-range attack is when the attacker has lots of time because the keys are already known, the public keys, and the attacker could spend months or years to try to figure out what the private key is. And this mechanism hides this public key on chain so that no long-range attacks are possible. However, short-range attacks, they are still possible. So that means when you spend Bitcoins, your public key needs to be briefly exposed in the mempool before the transaction is confirmed. And post-quantum signature schemes still needs to be added for these short-range attacks. And one of the co-author estimates 7 years for a full migration if work starts today. Bitcoin's last consensus upgrade took nearly 4 years just to activate, and after that, every wallet, exchange, and custodian still needs to upgrade. And the core problem, centralized systems can push updates. Bitcoin cannot push it that easily. Upgrading a decentralized network where no one is in charge is a bit harder. So that's it for this week. See you next week.